Now, in this example, we will find the derivative of the function by using or applying the properties or theorems of the derivative of algebraic functions. So for number 1, the given function is y equal to 4x cubed minus 12x squared plus 6x minus 12. Now, finding the derivative of y with respect to x, which is also be considered as y prime, is just simply applying the power derivative, wherein we can bring down the exponent and then less 1 from the exponent. So bring down the 3 multiplied by 4, that will be 12, and then less 1 from the exponent, that will be x raised to square, and then minus, for the next term we have to bring down the 2 and then multiplied by 12, so it is now 24, and then multiplied by x raised to 1 because 2 minus 1. And then for the 6x is just simply 6 because derivative of x with respect to x is equal to 1. That's the property, the derivative of a function with respect to itself. And then minus 12, wherein that derivative of constant is 0. So finally we have the derivative of the function y with respect to x, or simply as y prime, is equal to, factor out the common, which is 6. So 6 times the quantity 2x squared minus 4x plus 1. Now for number 2 example, this is also an example of power derivative, which is the function y equal to u raised to n. Now the given example here is y equal to square root of 3x plus 4, or we can consider this as quantity 3x plus 4 raised to 1/2. So this is an example of power derivative, wherein we can consider the quantity u as 3x plus 4, and then the exponent or the power here is 1/2, which is the n. And then since we have to multiply with the derivative of the u with respect to x for the power derivative, so might as well that we have to find the derivative of the u right away. So if we will consider the quantity u as equal to 3x plus 4, then the derivative of the u with respect to x is now equal to 3, because derivative of x with respect to x is 1, and derivative of 4, which is constant, is 0. And then the derivative of the function y with respect to x is now equal to, by power derivative, we can bring down the exponent as 1/2, and then the quantity 3x plus 4 raised to 1/2 minus 1 is negative 1/2, and then multiplied by the derivative of the u, which is equal to 3. And then simplifying, we can multiply the 3 by 1/2, so this is now 3/2. And then the quantity is 3x plus 4 raised to negative 1/2. Or if you want to, you can also express as 3 over 2, and then since this is raised to negative exponent, so we can bring it down to denominator so that it becomes positive, and this is now the derivative of y with respect to x is equal to 3 over 2 square root of 3x plus 4. Now the next example, number 3, is an example of power derivative also, but this time this is raised to square. So we have y equal to 2x squared plus 3x plus 6 raised to 2. So we can consider this as an example of the power derivative, wherein this is equal to u raised to n. Then we can consider again that the quantity u is the 2x squared plus 3x plus 6. And since we always have to multiply with the derivative of the u with respect to x, the derivative of the function y, so we have to find the derivative of this function u as power derivative. Bring down 2 multiplied by 2, that will be 4, and then less 1 from the exponent, so this is now simply equal to x. And then derivative of 3x is now equal to 3 because derivative of x with respect to x is 1, and derivative of 6 as constant is 0. And then for the function y, this is now the derivative of y with respect to x, or simply y prime, is, by power derivative, we have to bring down the power as 2, and then the quantity, and then less 1 from the exponent, so 2 minus 1, this is only raised to 1, and then to be multiplied by the derivative of the variable u with respect to x. So we have to multiply by quantity 4x plus 3. So this is our final answer for the derivative of the given function. And then for number 4, f of x is equal to the fifth root of x squared plus 3. This is another example of power derivative wherein we can also express as the quantity x squared plus 3 raised to 1/5. So this is an example of u raised to n. Then similarly, since we have to multiply the derivative of the function as with the derivative of the u, so we have to find the derivative of the u with respect to x as derivative of x squared. So this is another example of power derivative. Bring down 2 and then x raised to 1 because 2 minus 1. And then derivative of 3 is 0. Then the derivative of the function now can also be considered as f prime x. So this is also means the derivative of y with respect to x or y prime. And then by power derivative rule, we have to bring down the exponent as 1/5 and then the quantity x squared plus 3. And then 1/5 minus 1 is raised to negative 4/5 to be multiplied by the derivative of u with respect to x, which is 2x. And then simplifying, we can multiply the 2x by 1/5. So 2/5x, the quantity x squared plus 3 raised to negative 4/5. Or we can also express as, again, this is since a negative exponent, so we can bring it as denominator. So we have a final answer as 2x/5 and then fifth root of x squared plus 3 raised to the fourth power.